Okay, hello and welcome on to a tutorial on how to do a two-way repeated measures analysis of variance, also known as an ANOVA. So this analysis is quite common in sports science, exercise physiology research when you've got a fully within subject design, and it's probably the most common way that data is analysed in this scenario. But to a lot of undergraduate and postgraduate students, this is still quite a challenge for them to get their head around how to conduct and interpret this analysis. So hopefully this tutorial really clears things up. And in order for us to understand how this runs, I'm going to show you an example of some data from one of my PhD studies. And what this study did was we got a bunch of 12 participants. We got them to perform some exercise, so that's an isometric exercise task. Every minute of that exercise task, they performed a maximum voluntary contraction, where we acquired a measure of their maximum voluntary force. So that's our dependent variable, the thing that we measure. We essentially measured their maximum muscle strength at a series of time points. So that was it baseline, so also known as pre-exercise, and we measured it at 60 seconds, we measured it at 120 seconds, and then we measured it at task failure, so the point where the participants couldn't sustain that exercise task for any longer. And he also did this in two separate conditions. So the purpose of this study was to see how increased muscle pain impacted someone's ability to produce force throughout an exercise task. So we have in the white circles, the control condition. So they just received what's called an isotonic saline injection. Don't worry about what that is, but essentially that's the control condition that didn't cause any additional pain. And then the hype condition was the condition where participants received a hypertonic saline injection, which elevated the level of muscle pain that a participant experienced during the exercise. And we measured the MVC, the maximum voluntary force, at each of these time points in both conditions. Now, to describe this in a technical sense of an ANOVA, what we have is two factors. So that's why it's called a two-way repeated measures ANOVA. Factor 1 is our condition, so control and hype. So the factor of condition has what we call two levels. So level 1 control, level 2 hype. So I'll just write that out so it's there. So factor 1 is condition, and I've got control, hype. Alright, then we've got our other factor, which is the factor of time. So I've got 4 time points here. We've got baseline, 60 seconds, 120 seconds, and task failure. So level 1, level 2, level 3, and level 4. So level 1, we'll call that a baseline, even though it's pre. Level 2, we'll call 1 minute. Level 3, 2 minute. Level 4 is task failure. So overall, we've got 8 different levels and factors combined, because we've got the control condition and all the time factors in there. So control, baseline, control, 1 minute, control, 2 minutes, control, task failure. And then we've also got hype, baseline, 1 minute, 2 minute, task failure. So you essentially just multiply the number of levels in one factor by the number of levels in the other factor, and that'll tell you how many kind of aspects of your data that you've got. So in this case, 2 times 4 is 8. And we need to put this like this, breaking each factor down by its level in our statistical software. So I'll show you how that's been done. in the software JAMOVI. So you can essentially see on the top columns we have each factor of each level. So we've got control baseline, control 1, control 2, control task failure. So that's these dots here. And then we've got the same for the hype condition. So you just essentially need to get your data sheet and you need to paste the data organized like this into JAMOVI. And each row of data is a participant. So in this study, we've got 12 participants. So I've got 12 rows of data. So if I just spot check one of the values, this is participant 6 data for the value that we got in our control trial at minute 1 of exercise, which is 559 newtons. When you input your data into JAMOVI, you've just got to call it an appropriate variable name, so it doesn't really matter what you call it as long as you can identify it. So in this case, I know that this is the control condition from minute 1. So now once we've got our data sorted out and like this, we can proceed with conducting the two-way repeated measures ANOVA. So go to the top button and press ANOVA, then we'll go down to repeated measures ANOVA, and then it's going to open this analysis window. And what we need to do is tell JAMOVI what are the factors that we have in our study and what the levels within those factors. So it says RM factor 1, that's repeated measures factor 1, and that will be condition. So remember we had condition as a factor, and that had 2 levels, control and hype. So I'm just going to write those in here, and then I'm going to go to repeated measures factor 2. So our other factor was time, so I'm going to write that in there, hit enter, and then I'm going to put in all the levels of that factor. So baseline / pre, minute 1, minute 2, task failure. Just to note here that it doesn't matter specifically what these are called. They don't have to match exactly what these variables that you've named here are called, as long as you know which part is which. You don't want to get confused. So what you'll see is once we've done that and configured that correctly, underneath under the repeated measures cells, we should have 8 cells, because remember we had 8 levels across all of our factors, and it tells you which one is coded here. So this first one is the control condition at the baseline / pre time point. Then we've got control at the minute 1 time point, and so on and so on. So what we just need to do now is marry up these data points from the left hand side, move them across into this right hand side. And this is really straightforward. So we can see we've got control baseline first. We're just going to move that to control baseline. The second one is control minute 1. That's control _ 1. And then control 2, control task failure. Then we've got hype baseline, hype minute 1, hype minute 2, hype task failure. It's all married up now. And what you'll see is that once you've put them all in, you've populated all the cells, we will get a output from our repeated measures analysis of variance. But what we need to do first is we need to check some assumptions of our two-way repeated measures ANOVA. And what we do there is we come back to this left side and we need to check 2 assumptions really. So we need to check the assumption of sphericity, which is essentially are the variances equal between each combination of each level of each factors. So this will only apply when you've got more than 2 levels in your factor. So for this case it will be the condition by time, and time is where we'll check sphericity. So we'll check that, and then we'll also check Q to Q plots as well. So we'll cover the Q to Q plots first, and this is a test of the normality of the data. So what this means is that does the data follow a normal distribution? And that's tested with something called the residuals. And what we essentially need to do with this Q to Q plot is ensure that the dots here follow this line. And as long as these dots reasonably follow this line, we're probably okay. The two-way repeated measures ANOVA is fairly robust to violations of normality. So as long as this isn't completely off, then we're okay. We can see that we've got a little bit of skewness at each end of the data, but on the whole, it reasonably follows normality. So I would be okay with that. If the data was not normally distributed, we would have to consider something called a log 10 transformation, but that's beyond the scope of this video, or a non-parametric equivalent test. So we'll go to the next assumption then, is that assumption of sphericity, and that is this table here. And it tests it for each factor and a combination of factors. So if a condition, it says, nope, you don't need to worry about sphericity here because there's only 2 levels in that factor, so it doesn't matter. But if we look at time, that p-value is less than 0.05, which is our alpha level for these tests. So if it's below 0.05, then we assume that the assumption of sphericity has been violated. So in this case, we've got it as a violation for the time and the condition by time interaction. Now that's not a huge issue because what we can do is correct for that. The way that we correct for that is by checking this greenhouse Geyser box. So what you'll see is when I've checked that box, it's popped up a bunch of new p-values. And it's just slightly adjusted the p-values and the degrees of freedom to account for this violation of sphericity. So now we need to actually interpret the repeated measures ANOVA. So the first thing that we want to look at with this repeated measures ANOVA is this condition star time. And that's also known as the interaction effect. That essentially means that our data changes differently over time between conditions. You know, the trajectories of the changes are different, or another way you can look at it is the change of one factor is dependent on the change of another factor. And the way that we typically see an interaction manifest is through when the data has non-parallel trajectories. So if I look back to the figure that we have, we've got non-parallel trajectories here, and it's particularly this start portion that's doing it. So you can see in one condition it seems to decrease linearly, but in the hype condition we get this sudden drop, and then it tends to drop after. So in one condition we've got a linear decrease, and in the other condition we've got this bend which then decreases. So it's not really parallel. So we've seen an interaction effect there. So if you have this interaction effect, we're reading this p equals 0.007 line, we then need to explore that interaction effect. If we didn't have an interaction effect, we would then interpret the main effective condition. So this means that irrespective of the time points, if we collapsed all the time points together, would the values overall between the two conditions significantly differ? And then the factor of time is if the conditions were collapsed together, so if we squash together the control and the hype conditions, does this MVC force change over time? We can see that they're all significant, but it can be misleading to interpret the condition or the time effects in the presence of an interaction effect. So always start with the interaction effect. If this would be above 0.05, i.e. there's no interaction effect, then you would interpret these, what are called the main effects, by themselves. Okay, so the way that we can probe this interaction effect is we can do one of two things. We can go to post hoc tests, and then we can drag this condition by time interaction across. And this is a bit computationally intensive for a moment. So this is just comparing all of our levels of all of our factors to each other. So this is a really nice straightforward way to get a better understanding of our interaction effect. However, the issue with this is that it is comparing everything with each other. And our scientific question was, do people fatigue more quickly? Do people have a greater reduction in force with the increased pain? So most of these comparisons that this post hoc test does isn't actually that informative. So I'll give you an example. So if we look at the control baseline time point, that's compared it to every other time point. So if it's even compared it to the hype condition at minute 2. So comparing the baseline from one condition to the hype condition at minute 2. That's obviously significantly different, but that's not really a meaningful comparison. What we want to do is compare the time points that actually are at the same time point. So really we want to compare the control and hype condition at each time point. So we want to compare hype and control at 60 seconds, i.e. minute 1, hyper control at minute 2, and hyper control at task failure. We could also compare hyper control at baseline, but this is a within subjects design and the study was randomized, so there's no real point in comparing these because they're not going to actually be that informative. So instead of doing that, what I'm going to do is I'm just going to manually do these post hoc tests. So I'm going to go to t-tests and paired samples t-tests, and then I'm going to just do paired samples t-tests on those comparisons I just described. So control 1 versus hype 1, control 2 versus hype 2, control task failure versus hype task failure. Okay, and what this is given is the p-values for the different comparisons at different time points. So you can see at minute 1 it's 0.005, significantly different. At minute 2, 0.021 is significantly different, and at task failure is 0.092, so not significantly different. And that kind of correlates nicely with the graph that we've got. So we can see that there's differences here, quite evidently, but when they get to task failure, there's not too much of a difference there. So, based on this, we would say that there was a significant difference at minute 1, minute 2, but not task failure. And we can get a whole bunch of different stuff with our paired samples t-tests. So we can get effect sizes, mean differences, etc. But overall, we report the interaction effect doing it the standard way, and then we would then report the post hoc tests like this. Okay, hopefully that was informative.